We have data. One thing you notice is that they don't give us a function, and this is most common type of question. This is almost on every single AP. And therefore, on your test, did I get your attention? Okay. So we'll have to approximate this thingy, okay? This integral, whatever that means. And they ask you about the meaning of this integral too. But then you notice that absolute value here? So we have to take absolute value of these things and evaluate. That gets pretty complex. So my suggestion is, and it's a very good suggestion, you plot this out. So we're going to do that, okay? So let's plot this thingy. Let's say it's about yay big. Make that black, okay? I'm gonna move it up slightly to have more room. Now, so whenever we plot this, we have to make these things positive. Good? Okay, so 0, 20. I know we only need it from 30 to 60, but I'm going to demonstrate how to find all of it. Okay, it doesn't take that long, and it's very valuable lesson. And I want to leave this as a recording. So at 0, this is 20, positive 20, because we're taking absolute value. So let's plot that from here to, let's say that's 20. Whenever you do this, I write 0 here at the bottom and 20 up here. Later you will see why this is such a wise thing to do. And then it jumps up to 15, right? So I'm gonna throw another vertical line and always plot it in this procedure. Let's say this is 15. So 15 and up to 30. So let's say 30 is yay big. Oh, that's too high. How about here? So this is 15. And this plot, this point is 30. So far so good? Not confusing, right? Oh, one thing you notice is this delta x's, or in our case delta t's, are not uniform, so you cannot factor it out. That's why I told you not to factor it, because they give this kind of questions on AP. This gap, it'll change. First it was 15, but from 15 to 25, this is only 10. You know what I'm saying? So the 10, let's say, is here, is narrower. What? How did that happen? Okay, stand it up, and it goes back to 20, so let's say it's here. Move it to the right just a tiny bit. Okay, so let's say this is 25, and this is back to 20. You with me? Okay, next one is 30, so it only jumps by 5, so it's narrower gap, and it's 14. It's half as much, and then it, let's say 14, that's 20, so 14 is about that much. So this is 30 here, and this is 14. And then 35, also another gap of 5. And then we're supposed to go up to 10 this time. So let's say here's 35. And then up to 10. Let's say 10 is about that high. So this is 35 and this is 10. Is anybody confused about how I plot these things? And these vertical lines come in handy, so just I keep drawing it automatically. And then after that is jump of 50 and it's 0. 50 is big jump, let's say it's here. Okay. And then 60 up to 10. It ran out of space, but it's okay. I think I can. 60 is about here. And back up to 10. Too big. Okay. So this is 60, and this is back up to 10. So far with me? I mean, Somebody asked me during second period, do you have to draw these curves to connect this? Well, you could if you want to, but they're useless. They really don't help us in our approximation. Now, what we have to do is calculate left rectangle approximation, okay? But this part is exactly same so far. It was originally trapezoid approximation, but you haven't learned how to do that yet. So let's go with rectangle. I changed to left rectangle. What is left rectangle then? Left rectangle means the rectangle has to exist like this. You get it? The green color. So that's my rectangle. Left corner has to be on that data point. Okay. Let's do another one. So next one should be that big. Good. And this one should be that big. And next one, it's right there. This one, that one did not work out. Okay, now while I'm at it, I know why. I know I may know, but why am I so when it comes to these things? Okay, and this last one, that one has a height of 0, so it's not exactly a rectangle. You know what I'm saying? So this is what it looks like. Suppose we have to calculate the integral of all of this. Then all you have to do is find the area of these things, right? So let's calculate the area together, shall we? This is 15 and this is 20. So do you see this is 300? This is 10 and this is 30. So that's another 300. You see how easy this is now? You see the wisdom of writing this height on top? So you don't have to look at the table and potentially mess up. This is 20 and this is 5, right? So this is 100. This is 14 and this is 5. So is that 70? And this is 10 and this is 15 again, right? So this is 150. Done. Now, notice that we never use this data point. This is a left rectangle, so you don't want to draw another rectangle out there because, like, what? Where does it end? It goes infinity. On left rectangle, if you've been doing your homework honestly, you always throw this right one out, right? If it's the other way, conversely, if it's a right rectangle, if it's thrown this way, then you have to throw this way. Good? Question about this. Okay, now we'll answer the question here. So go back up here. We have to calculate this. So this is part A now. So this thing from 30 to 60 of dt absolute value, which is what we plotted, dt. What is this thingy? Well, it's just the area of the rectangle between here and here, but just those two, because this is 0, isn't it? So that's 220. There are two mistakes I just made intentionally. Somebody catch both, or one each. What are my mistakes? Huh? What was it?
Missing a unit?
Unit, of course, right? As mathematicians, whenever you write 220, 220 what? I mean, this number should look very naked and ashamed, right? You cannot write a number without a unit. But then a lot of students write meters automatically because it's not meters, it's feet. You get it? It's not feet per second, it's feet. Why is it feet? Because this thingy is your velocity, which is given in feet per second. And this is your time, which is given in second. You know what I'm saying? So the unit-wise, this height is feet per second, and this width is second, and seconds cancel when you multiply. Ah, so this unit is feet. What's another mistake?
Is it the equal sign?
What?
You have to make the equal sign approximation.
Oh yeah, this is not exact. This has to be approximately equal to. You know what I'm saying? It's the whole thing is a rectangle approximation. Real function is the area under this curve, and there's no way this is the same thing. We don't know the function, so we can only approximate. You get it? Okay, so make sure people lose a lot of points on the test after getting the correct answer. That's gonna suck a lot. So don't do it. Then, what is this thingy? What is the meaning of this thing? The unit is feet now. Because it says, give a meaning of the integral with the correct units. Right? Meaning of this in terms of course motion. What is the meaning of this integral of absolute value of velocity function? It's in feet.
The total distance traveled between 30
This is a distance. My pen does not want to write anymore. Computer stuff. This is a distance. You get it? So this is distance traveled. Traveled. Learn to spell. I still misspelled it. Between, on, let's say between t is equal to 30 and 60, right? During. Let's just do it this way. 30 to 60. How about that? And even here, you have to write unit here. You get it? Then I have a question. I'm going to change the color. What is this thingy? 30 to 60, just v of t dt, without the absolute value. Number one, what's the value?
Displacement.
That's the displacement. You get it? This is delta x. And you're supposed to get negative 220 feet. Do you see that? Because the values here are negative values, right? We just took the absolute value and drew it this way. It would be negative, negative. So this would be down here. You get it? And that's, in other words, cars going backward. Good. So this is distance. I mean, this is a displacement. Of car. How about that? You get it? This is a huge concept in calculus. Integral of velocity gives you the displacement, and integral of the speed, this is a speed, absolute value of velocity. Speed gives you the distance. Don't mix those two up. I'll take points on the test. Now, when these values happen to be positive, these two give you a same value, but still, if I ask you about this and if you write distance, I will take points. You're still incorrectly answering the question, right? Distance and the displacement in that case happen to have the same value. That doesn't mean they are the same thing. Okay, there are two different things in physics. So you cannot mix those two up, distance and displacement, okay? And then this is almost the definition of displacement and distance. What you're integrating are two different functions. And when you get into 3D vector function, this makes a big world of difference. Okay? Now, then that's A part. So let's answer B part. It says we have to now explain the meaning of this. from 0 to 30 of acceleration. If we integrate acceleration, what do we get? And let's get the value first, but it says exact value. What? We don't even know the function. So how do we get the exact value with these thingies?
It is the velocity.
Huh?
Velocity?
Wait, you're breaking up? Speak again.
The version of acceleration is velocity.
I still can't. I think what you said is, you see, this is misleading. We don't even want approximation, right? It's just there to throw you off. Let's think like this. Remember antiderivative trick I taught you yesterday? What's the antiderivative of A? It's V from 0 to 30, right? But what is this thing? This is V at 30 minus V at 0 now, isn't it? And we have those values given to us. V at 30 is negative 14 minus negative 20. You get it? So this becomes negative 14 meters per second. Oh, meters. Oh, I did it again. Feet per second. Feet per second minus negative 20 feet per second. So what we end up getting here is positive 6 feet per second. You with me? So what is the meaning of this then? What is this 6 feet per second? And the key is right here, this minus this. What is it? Feel free to use your microphone.
Change in velocity.
Yeah, change in velocity. How do you not see delta V here? V something minus V something is change in velocity, isn't it? So this is change of velocity, change in of English grammar. Velocity during 0 to 30 seconds. You get it? You see how AP will try to throw you off by giving you meaningless data of acceleration, eh? How about that, huh? Yeah, you can definitely expect this type of problems on your test and on the final and on AP. Okay, any questions before I move on to the property of integrals now? Then property of integrals. Okay. Do I have time for this joke? I think I do. Let's think about this one. If you switch the limits of integration, say your function looks like this. I'm going to make a copy of this because I'm going to need these things. Okay, say first, let's say your function looks like this. And then you're trying to find the integral between a and b. Okay, but b to a, what does that mean? If we use rectangle approximations, right? Say you're using these kind of rectangles here. And remember how we calculated this rectangle's area? When you are doing tomorrow's quiz, right? This is ft. This is f of x asterisk here. And this is delta x right here, isn't it? And delta x was b minus a over n. But if you do it backward from b to a, then it's a minus b over n. Then you see that each delta x becomes a negative value. So each of these area becomes negative now, doesn't it? Do you see that makes sense? It's the other way. You can think of it as an antiderivative idea because this first thingy, you have antiderivative, whatever, we'll call it this thingy, and we have b, a here, and then versus antiderivative here, and this is a to b. So it's like f of a minus f of b versus f of b minus f of a. You see why they are opposites? So that's kind of what it means. But I like this idea better, going backward. Okay, imagine rectangle approximations. So far with me? Okay, I'm gonna finish this and I'm gonna tell you a joke to enforce this, to remember this. Okay, now, is it exactly 0 then? That makes sense to you? A to A, your rectangle is infinitely thin? Yeah, so let's not even draw this thingy. What about this thingy? K times f of x, what does that mean? Okay, say our function is like this. I'm gonna bring it down a little. Erase it. God. This thing is, so say our function is like this, okay? But if you multiply by k, let's say k is equal to 2, then is that a vertical stretch like that? And we're trying to find this area from A to B. So this is a vertical stretch by k, isn't it, factor of k? Then does that tell you this area under blue curve is exactly k times bigger than the original area? That makes sense to you? Okay, and in particular, if k is -1, that means vertical flip. So it's the exact same area, but it's opposite because anything below the x-axis happens to be negative. Okay, so that's that one. Talk about this one. So if you have f and g together, then would that be, I'm gonna get rid of that one and bring this one up. What does that look like, right? Say function f looks like this. And then function g, now you're adding it, right? So function f has these kind of rectangles. From A to B. And function g, whatever it is, we're stacking it on top of this. It might be bigger and then smaller and then this is function, this function is f plus g now. You get it? So total area is there, so that would be the same thing as calculating this red area and calculating the blue area and then adding that on. That makes sense to you? Okay, you have to think of it as rectangle approximations. Now this one I'm going to bring it up here. Okay, this one, let's say my function looks like this. Okay, and area from A to B, this is A, and let's say that's B. So that's this area, right? And then that versus area from B to C, and it's that area right there. Would that be same as area from A to C, the total area? You get it? Yeah, of course, that's true then. If you think of this as an area, then all of these things, don't memorize it, it has to make perfect sense. Good? Okay, now this is a biggie. This is a biggie, okay? So let's use that one. This one, I'm gonna make this thing a little bigger. This is huge. This is leading up to the proof of the fundamental theorem of calculus. Okay? So let's say my like this. Okay? And this, of course, is point A, and this, of course, is point B. Let's calculate the minimum of this thingy. Minimum of this thingy, of course, will look like this. Would this be the minimum of that value? This is the minimum, isn't it? So when I say the integral, that's area, this entire area, but when I say minimum, which is this high, times b minus a, and b minus a is this long, isn't it? So we are talking about this green area. So this green area, of course, is smaller than the integral area by that much and that much. How about that? That makes sense to you? The other way, of course, is this. The other way, I'm going to calculate the maximum value of that function. And maximum value certainly looks like this. This is a maximum. So maximum area up here is all of this rectangle area, isn't it? Maximum times b minus a. That's, of course, greater than this integral area by that much. That makes sense to you? Okay. The other thing is pretty obvious if you, it's just like direct result of this one. But this is a biggie. You have to remember this picture. Good? Any questions?